discovery. Okay, but we can look at things in a different way. And I want to actually have us think about looking at the difference and how these Fibonacci numbers are in fact growing, not just by subtracting and doubling, but by comparing them in some more fundamental way. In fact, one way to compare numbers is just to see how they are relative to each other. And in fact, that's where the word ratio comes from, by looking at comparing two numbers and dividing one into the other and seeing how they compare. So in fact, another way of looking at the issue, which is a wonderful thing, by the way, as a life thinking strategy, is to look at issues from several points of view. Once you have one perspective, it's always wonderful and sometimes extremely valuable to force ourselves to look at it from a different perspective, a different vantage point, and again, we reveal hidden structure, new insights. So in this case, let's actually, instead of subtracting and doubling, let's take a look at how these numbers are growing by looking at how they're growing relative to each other, by looking at the ratio, the quotient, of two consecutive Fibonacci numbers. So in particular, I want us to look at how the fractions, one Fibonacci number divided by the previous one, how those fractions change. So let's take a look. What we see when we look at a table we can build, we'll just start taking Fibonacci numbers and dividing one into the previous one. So for example, the first one we can look at is take 2 and divide it by 1. Those are two consecutive Fibonacci numbers. If we divide them, we see the answer, of course, is 2. We take the next pair, 2 and 3, and we divide 2 into 3, we see 1.5. If we take 5 divided by 3, we get 1.666 repeating forever. If we look at 8 divided by 5, we see 1.6. 13 divided by 8, we see 1.625. And we can now scroll down and see a lot of these, which you can just compute on a calculator. For example, 89 over 55 is 1.618118 forever. And if you scroll down a little further, in fact, a lot further, you'll find two consecutive Fibonacci numbers. One is 1,597. If we divide it by the previous one, which is 987, we see the decimal 1.618034448, and so on. Now let's do one more. If we do the very next pair, we'd see 2,584, pretty big Fibonacci number, divided by the previous one, 1,597. And that decimal works out to be 1.618033813, and so on. Well, when we look at this long list of decimals, something is striking. In particular, we see that as we move on down this list, the decimal number seems to be actually approaching something. Those fractions are getting closer and closer to each other, for they seem to be converging, if you will, on the number 1.61803 something. So they seem to actually be coming together.